Now in this video, we're going to look at using sum and difference formulas. So why would we need to do this? You would need it because sometimes we're asked to do this, sine of 405 plus 120. Well, wouldn't that just be the sine of 525? Well, that's not in the unit circle, is it? And in 525, if you subtract 360 to see how many, if it's a coterminal, then that is 165. But that's not on our unit circle either. So then we don't know what to do. So we can't just distribute the sign. It doesn't work like that. All right, so what we have to do is break up the angle into two things that are on the unit circle. So 405 will work because 405, just so you know, if I subtract 360, that's a coterminal to 45 degrees. So we can think of it as 45 degrees. 405 plus 120 is 525. And if I use this formula, I can find the sine of 525. And I find it by breaking it into two angles that are on the unit circle and establishing these relationships. So if this is sine, this is a sum equation because it's a positive right here. Then I would look on my chart and I would look at sine of two angles added. Now this one line right here has the two angles added and subtracted formulas built in. So look at the pluses and minuses. So if I'm adding u plus v, then I would take the sign that's on the top here. Sine of the first angle times cosine of the second plus cosine of the first times the sine of the second. So you want to establish when you do this which one is u and which one is v. And then you're going to rewrite with the formulas in place. Okay? So I'm going to zoom in just for a moment. So I'm going to do the sine of u plus v, and the formula says that it's the sine of u times the cosine of v plus the cosine of u times the sine of v. All right, so if I put this then in context, I need the sine of 405 times the cosine of 120 plus, and then we do this product, the cosine of 405 times the sine of 120. Now, you're going to want your unit circles or a really good memory to be able to pull these values, right? So sine of 405 is the same as 45 degree angle. So if I choose that, 45 degree angle right over here, what is the sine? It's square root of 2 over 2. Times the cosine of 120. Well, where's 120? Right here. What's the cosine? It's negative 1/2. Plus, and then let's do this over here. The cosine of 405, which is the same as 45, so it's square root of 2 over 2, times the sine of 120. Where's my sine? It's the y, square root of 3 over 2. All right, so now we just clean it up. When we multiply fractions, remember top to top, bottom to bottom. And when I do that, I get negative square root of 2 over 4. Notice they're going to have the same denominator. And then over here, when you multiply radicals, you multiply the insides to each other. So it would be the square root of 6. So this would be the sine then of that angle. Okay, so you might ask yourself, well, is the sine what we just did of 405 plus 120, is it equal to just the sine of 405 plus the sine of 20? Like kind of distributing it out. Well, let's find out if it's the same. So the sine of 405, remember, is the sine of 45 degrees, and we said that that was just the square root of 2 over 2. And the sine at 120 is square root of 3 over 2. So I get the square root of 2 plus the square root of 3 all over 2. Well, that is a very different answer than what we got over here, isn't it? It's very different. So they're not the same. So when you have two angles that are added in parentheses and you want the sine or any trig function of that, then you're going to be using these sum and difference formulas to find it. All right? Let's look at number 2. Okay, so number 2 is the sine of the sum of 2 pi over 3 plus 5 pi over 6. So now look, we're in radian mode, aren't we? So we're going to do this with the sum and difference formula in part A and part B. We're going to see if is it the same when you just distribute it out. Okay, so let's do the sum and difference formula. So we're actually going to be using the same formula we did in the previous example because it's sine and it's a sum. What's different is that the angles are in radians. That's all. Okay, so I'm going to say the sine of my first angle is 2 pi over 3 times the cosine of the second angle, 5 pi over 6, plus cosine of the first angle, 2 pi over 3, sine of the second angle, 5 pi over 6. So we do the products first and then we add them. Okay, so look at our unit circle. What is the sine at 2 pi over 3? Well, it's right here. Square root of 3 over 2. It's positive. Cosine of 5 pi over 6. Well, where's 5 pi over 6? That's over here. What is the cosine there? Negative square root of 3 over 2. Then we have a plus sign between them. The cosine at 2 pi is the x value, so it's negative 1/2, times the sine at 5 pi over 6, that's the positive 1/2. All right, let's multiply this. Square root of 3 times square root of 3 is 3, and it'll be negative over 4. Negative times a positive will make this negative, right? So it's going to be minus. 1 times 1 is 1, 2 times 2 is 4. So I have negative 3 minus 1 over 4, which simplifies nicely to just negative 1. All right, well that's lovely. What about B? What if I distribute the sign? Let's see what happens when we do that. Well, if I do that, the sine at 2 pi is the square root of 3 over 2 plus the sine at 5 pi over 6. Well, that's 1/2. Well, that's just the square root of 3 plus 1 over 2. Those are not equivalent, okay? They are not the same. So you want to be really careful on how you approach these. Now, let's look at the next type. Okay, now our question says, find the exact values of sine, cosine, and tangent of the angle. And the angle they gave us on number 3 is 15. Well, that's not an angle on our unit circle, is it? So what we're going to have to do is find a combination of angles that are located on the unit circle that would get us to 15. So you have options here. I'm going to use the combination that jumps out to me that would get me to 15. I can do 60 minus 45. I could do 45 minus 30. Doesn't matter which combination you get, you should end up with the same result. So I'm going to use, let's see, I'm going to use the fact that 60 minus 45 will give me 15 degrees. So I'm going to use a difference of 60 and 45 to get my 15. You can use 45 and 30, that's fine. But we're going to have to find all 3 of these. So let's use our space wisely. Let's find the sine first. So the sine of 60 plus, or minus 45, I'm sorry. If I follow the formulas, it's going to say the sine of 60 times the cosine of 45 minus the cosine of 60 times the sine of 45. Okay, I'm going to use my unit circle to help me find those values and plug them in. So the sine at 60, where is that? Sine is square root of 3 over 2 times the cosine at 45 is positive square root of 2 over 2 minus the cosine at 60 is 1/2. Times, sorry, not comma. And the sine at 45 is square root of 2 over 2. So when I clean that up, I'm going to have the square root of 6 minus the square root of 2, and all the denominators are 4, so there's my answer. Now let's try this with cosine, a difference of cosine. So we're going to use a formula we haven't used yet, but it's on your chart. Nothing to worry about, just follow the formula. Notice if it's subtraction, I'm using the bottom sign. U minus V, cosine of U, cosine of V, plus sine of U, sine of V. So it's a little different. Just follow the pattern and you've got this, okay? So we're going to start with cosine. So we're going to do cosine of 60 times the cosine of 45 plus the sine of 60 times the sine of 45. Let's see what we get. The cosine at 60 is 1/2. Cosine at 45 is square root of 2 over 2. Pulling these straight from the formula chart. I'm sorry, the unit circle. The sine at 60 is square root of 3 over 2. The sine at 45 is square root of 2 over 2. So if I clean this up, what do I end up with here? Square root of 2, all of it's going to be over 4, plus the square root of 6. All right, so there's my cosine. Now let's do tangent. Tangent's a little different, okay? So if you look at the equation for tangent, notice this. This is tangent of u plus or minus tangent of v, right? So if I'm adding, I add on top. If I'm adding, I subtract on the bottom, 1 minus the product of the two tangents. And vice versa if I'm subtracting. And so in my example right now, we're subtracting. So let's go back. We're going to use our formula to get us there. Now what would be helpful, notice we need to know what the tangent of u is and the tangent of v. So it would be helpful to kind of take a sidebar here and go, okay, what is the tangent at 60 degrees? Well, look at our unit circle. At 60 degrees, that's a pi over 3 angle. So if you use my little trick, that means the tangent is square root of 3, and it's positive because it's in quadrant 1. Now what about the tangent of 45? Well, the tangent at 45 is square root of 2 over 2 divided by square root of 2 over 2. So it's nice and easy. It's just a 1. Those are the values we're going to use in our notes here as we do the tangent formula, okay? So it says the tangent of 60 plus, it's always the opposite sign, tangent of 45, all of it over 1, make sure I get this right. Oh no, I'm sorry, it's subtracting on top, isn't it? If I'm subtracting. Subtract on top and then I add on the bottom. The product of the tangent of 60 times the tangent of 45. Okay, so we said the tangent of 60 is square root of 3 minus 1. 1 plus, when I multiply those two, it would be just the square root of 3, right? Okay, from here, we can't leave a radical in the denominator, so we have to multiply by the conjugate. Maybe you remember this, maybe you don't. But when we multiply by the conjugate, it looks like this. It's 1, and the sign's going to change, minus the square root of 3, and we do it on the top and the bottom. So it's equivalent to 1, but it's going to help us get rid of the radical on the bottom. So if I'm going to do FOIL. Okay, if I FOIL the top, I'll get square root of 3. Square root of 3 times square root of 3 is 3, minus 1 plus the square root of 3. On the bottom, if I do it correctly, the middle terms will fall out. So 1 minus the square root of 3 plus the square root of 3 minus 3. All right, yep, middle terms fell out. Let's clean this up. So I'll have 2 square roots of 3 and then minus 4 on top. And on the bottom, I'm going to have negative 2. Now I don't want that negative 2 in the denominator, so I'm going to factor it out. Okay, so it's going to be negative 2. When I do that, it's going to be negative square root of 3, and this is going to become plus 4 divided by 2 is 2 over negative 2, so this will simplify to negative square root of 3 plus 2. All right, so it's a little tedious, right? You want to give yourself space to do it, and you'll be fine. You will be absolutely fine giving yourself space to do it. On number 4, we're asked to find the same instructions of finding the sine, the cosine, and the tangent of the angle 5 pi over 12. Well, 5 pi over 12 is not on the unit circle, so it's going to be a combination of angles on the unit circle, but what makes it a little more challenging is that it's in radian form, right? Nothing's in 12ths, so we have to think about something that could be in the 12ths and reduce down to something on the unit circle. So we have a lot of options. So first of all, I would think about it like this. What pi over 12 plus what pi over 12 is going to equal 5 pi over 12? Well, if I do small values, it has to be small, right? What adds up to 5? Well, the 2 and a 3. Let's see if these reduce to something on the unit circle. That reduces to 1 over 6, so pi over 6. This reduces to a pi over 4. Those are angles on the unit circle, so it works. Now, could you do something different? Of course. You could do a difference equation. something pi over 12 minus something pi over 12 gives me 5 pi over 12. Well, let's think about that. I could do 8 minus 3. Would that work? What does this reduce to? Well, 8 twelfths would reduce to what? 2/3. That's on the unit circle. This reduces to 1/4, so pi over 4. That works. You can use whichever combination you choose, okay? And again, we're going to end up with the same answer. So we're going to be using our sum and difference formulas like we've talked about. So you have those handy with your formula chart, hopefully. I'm just going to move those down here. And I'm going to set up the question for you, okay? We're going to set it up and see where we go. All right, so I'm going to use this combination here. The one that is pi over 6 and then pi over 4. This one that we came up with right here. That's the one I'm going to use. So I'm going to say the sine of pi over 6 plus pi over 4. And if I use my formulas, it's going to be the sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. All right? Now I'm going to let you finish this one, and we'll see if you get it when you come to class. And we'll check that out next chance we get. So on your own, this one's an on your own question. And then you can set up the other ones, you know, cosine of pi over 6 plus pi over 4. Set that one up and finish this one, and then the tangent of pi over 6 plus pi over 4. We'll let you do those on your own, and again, we will check these when we get to class. Now the last thing I want to address in the video is write the expression as sine, cosine, tangent of an angle. So it's giving us the sum and the difference, and it's asking us basically to take the expanded version and condense it down. So it's taking the expanded equation and we're going to write the condensed equation. All right? So we're going from this side to this side now of our equation. So let's look at what we have. If you notice the patterns, you'll see this. It goes sine and cosine plus cosine, sine. So when it's sine and cosine, that's my hint that it's going to be something around the sines category. So sine. Then I decide, is it plus or minus? Well, if it's a plus in the middle, that means it was a plus over here. And then I just take those two angles. I take 110 plus 80, and I find then I can add those. That's 190. So that's all you're doing here, is tell me what to get it down to the right trig function with the correct angle. So look at number 6 here. Sine and cosines again, that's my clue that it is sine, but this time it's a difference. So it's 3.5x minus, I see that minus, 1.2y. Now, I can't do anything with that because x and y are different variables and I can't combine them. So that's where my answer stops on this, okay? So these condensing ones don't really take that long. But again, I want you to finish that number 4, and we'll check your answers when we get to class. All right, good luck. We'll see you there.